All right, so our first skill introduced us to the atom, the parts that make up an atom, and the periodic table. Our second skill told us how we can use information on the periodic table to determine how things are going to interact. Are we going to make an ionic compound or a covalent compound? Our third skill is the meaty sort of skill for this learning unit, and this is the skill that you'll have an individual in-class quiz on, which is naming compounds. So this skill is actually split into three little mini skills here. We're going to first learn how to name simple ionic compounds, and then we'll have a meaty middle section here where we talk about all the complexity that we can add into ionic compounds. And then we'll wrap up with kind of a simple discussion of simple covalent compounds. But again, this is going to be a little bit of a longer video because this is the important skill from this learning unit, naming compounds. So when we think about kind of our periodic table here, we have that information that tells us what we're likely to have to generate ions and what we call monatomic ions, so single atom ions. And most things that we're going to find on the periodic table are going to form one monatomic ion. But as we highlighted before, we have some of these guys in the middle that tend to have the possibility of having two monatomic ions. We call these transition metals, and they tend to have more than one possibility. Roman numerals is an easy way for us to indicate kind of which we have, and the Roman numeral will again be reflective of the charge, but we also have some unique kind of systematic names which use those Roman numerals, but then we have these odd common names that kind of have more of a historical context. So we'll look at some of those in a minute. Again, those common names tend to have the same early part of the name, but then they're going to have a suffix at the end. So we'll get to, in just a second, a slide that will kind of highlight that. So again, some of these things are just pieces of information that you have to memorize. So again, here's just another way to look at some common monatomic ions. So anything that's kind of shown here, it is a name that you need to know. So again, I told you need to know pretty much anything under the atomic number 40. And then there's some other ones that we do need to know, whether they're from group 1, group 2, group 8, group 6, or group 7 are things that we're going to need to know. So there's just some common names that we need to know. So one of the things that we need to think about when we are naming what we call binary ionic compounds, that's going to take one atom, one element from the left side of the periodic table, a nonmetal, and one nonmetal, so a metal and a nonmetal, to make this binary ionic compound. So again, each of those is only going to be one element, and so when we're naming these, we're going to name and list the cation first, so the metal is going to be listed first, and then the anion is going to be listed second. So when we're naming that cation, naming the metal, it's pretty simple. It's just whatever the name is on the periodic table. So for example, if it's sodium, that we make a sodium cation, we just call that sodium for naming. Same thing with calcium. Calcium would form a calcium 2+ cation. We would, in a naming sense, just call that calcium. When we name the anion, when we name the nonmetal piece of this, we need to do a little bit of modification, and we sort of indicated this when we were calling table salt sodium chloride in our last skill there. But how we're going to name things is we need to take the root of the nonmetal, and then we need to add the suffix or the ending part, IDE. And the more that you do with these, the more that things will just sound familiar, and you'll just recognize certain names, or again, if it's wrong, it will sound not right. So for example, if we're talking about chlorine, chlor is the root of that nonmetal, so we take chlor and we add IDE on it, and we get chloride. Oxygen, ox is the prefix, so we take off the igen and we add IDE, so it becomes oxide. Nitrogen, again, the ogen is the part that comes off, and we add IDE, so it becomes nitride. So the more of these that you practice, the more you're just going to have things that either sound right or don't sound right. So let's kind of talk about how this gets a little bit more complicated when we start having things that are not binary ionic compounds. We're not going to have things that are just a simple metal and a simple nonmetal. So we're going to start again talking about things that we find in the middle here of the periodic table. So again, we've got these common monatomic ions that we have in the extreme left and right. Then when we get to this middle section and we have things that we can find in multiple ways, that's where we get these unique names. So I kind of mentioned them already, but here's this table that kind of summarizes them. So again, we're still going to be naming things where the cation's first and the anion is second, but knowing that some of these metals can form more than one charge. The systematic name is the easiest way to be able to think about things because whatever is in Roman numeral tells you the charge that we're going to have on that cation. So these are pretty straightforward to see here. This is where things get a little bit confusing, and these are just things I just recommend having flashcards or something to help you study these. We can see that they'll have sort of the root sort of prefix part, and then we can add to that either OUS or IC. Okay, and usually these are going to have only two charges with them. They'll have a lower charge that we have the OUS, and then the IC is going to be for the higher charge. So just as an example here, we've got cuprous and cupric. So cuprous is going to be the copper ion that has the smaller charge. Now here again is where things get a little bit more complicated because you have to remember copper comes as a +1 and a +2. Something like iron comes as a +2 and a +3. Something like tin comes as a +2 and a +4. These are just things that you're going to have to memorize. It's just one of those toolbox knowledge things that you're just going to have to know so that you have it ready to kind of work in this skill. So sometimes we might have things that are more than one ion that comes together in what we call a polyatomic ion. Again, another thing that it's just memorization, right? If you're taking, a human anatomy course, you just got to memorize bones and muscles and things like that. This is our equivalent of that. We just have to name these compounds. We need to know what these pieces are. So again, I'd encourage there to be flashcards. I'm going to see about putting some flashcards up on Blackboard for you to be able to use as you learn these names. So again, we've got a few polyatomic cations. So we've got ammonium and hydronium, and then lots of different anions here. So these are, again, ones you do need to know the names of. So you'll notice that some of these ones that I have boxed in red here, they have chlorine and oxygen, but they can have different numbers of oxygen with them. ClO, O2, O3, and O4. They're all -1, but we need to know how to name those. So that's what this table is here for. Okay, it's just a way to help us remember that to name them, we're going to have whatever this root is, and the root is going to be chlor. So this is going to be a chlor sort of ion. And then the suffix is going to be telling us the number of oxygen atoms that we have with it. And I should say it's the prefix plus the suffix. So let's kind of run through this here. When we have the fewest number of oxygen atoms, we only have one oxygen atom, so it's ClO-. We're going to have the prefix hypo, meaning less than or underneath, and then we have ITE. So hypochlorite is going to be ClO-. And let's just kind of tick up one oxygen atom at a time. When we go to ClO2-, well, we get rid of the hypo prefix, but we leave the ITE, so that's chlorite. Go up one more oxygen atom to ClO3-, and the ite becomes 8. And then when we have the most situation, we're going to be perchlorate. So this is just a little box that helps us remember how this works. And one other thing, it's not on this table. Chlorine is a halogen. There's 3 other halogens that could do this. We could see brome for bromine being in there, or we could see iodo for iodine being in there. So there's actually a total of 12 different halogen oxygen sort of species that we could see there. Okay, so again, we've got these ite and ates that we need to think about. Okay, and then hypo and per that we're going to see as prefixes. So just some things that are going to help you remember sort of this systematic naming that we see for these polyatomic ions. But everything that's listed in this table are just things that you have to know. This is a crucial skill to moving on in chemistry, is knowing how to properly name things. Because a lot of times you're going to see a problem where all I'm going to give you is the chemical name. From that, you need to be able to create a formula. And then from that formula, you need to be able to do a problem. Well, if you can't get the right formula, you're not going to get the right answer to the problem. So that's why this is the critical skill that we're going to have a separate quiz on in class for this problem, for this learning unit. So a couple of little extra things that we're going to have here. We're going to have hydrates, okay? Hydrates mean they have water attached to it. So hydrates are going to have a specific number of water molecules that we'll have attached to it. So what we do then is we would name the salt, and then we're going to add the word hydrate at the end using a Greek prefix to tell us the number of water molecules. So for example, this would be magnesium sulfate. That's how we'd name that salt. And there's 7 waters with it. So we would say heptahydrate. Hepta meaning 7, and then hydrate meaning water. So you do need to know the Greek prefixes that we have here. So that's going to become an important, another one of your things to add to your flashcards. All right, the last thing here, and this is where we really start getting in the weeds. We're not going to name a ton of acids. So if you're starting to feel overwhelmed, just leave acids for a little bit. It might be one that you'll get wrong, but again, we're not going to have a ton of acids, but we do need to know how to name acids. So acids we defined as any anion that's connected to a +1 hydrogen ion, this H+. We call that a proton. Okay? So things that we define as binary acids are things that would be a gas normally, so a hydrogen attached to something else that would normally be a gas. If you bubble that into water, it's going to make an acidic solution. So things like HCl and HCN are what we call binary acids. So how you name those, and you probably already know this guy, this is hydrochloric acid. Well, here's the systematic way for how that works. We're going to add the prefix hydro. We're going to add the root for the nonmetal, which is chlor for this guy, add the suffix IC, and then we're going to have acid. So again, this is hydrochloric acid. You probably already knew that. This guy is going to be hydro. This is cyanide as a polyatomic ion, but cyan is going to be the prefix. So hydrocyanic acid. That's how we'd name that guy. Now, the good news is that there aren't a ton of these, so you might be able to just kind of memorize them, but I think it's important to kind of understand how that works rather than just doing a strict memorization. All right, oxoacids. So do you remember on this last page over here, we showed you all of these halogen-oxygen polyatomic ions. All that we have here with a lot of these oxoacids are taking that polyatomic ion as an anion and mixing it with hydrogen as a cation to make an acid. So basically, we just need to think about whatever that oxoanion was, and then we make 2 changes to it. So if we had ATE in the anion, we're going to make it into an IC. Okay, so let's go through just a quick example here. If we had, and again, if we're doing this first one, if we had ATE, so let's take chlorate here. So chlorate would be ClO3-. So if we made that as an acid, it would be HClO3. And again, that +1 and -1, those would go together. So if we got HClO3, the anion was chlorate. So what we do is that 8 becomes ic. So now that would be not chlorate, but chloric. And then we add acid to the end. So that would be chloric acid. Note if you have, this should be hypo and per. Let me correct that on here. If we have hypo and per, we're going to retain those in the name. So for example, if we had this guy here, we had perchlorate. If we had perchlorate here, we would keep that per, and it would become perchloric acid. So acids can get a little bit dicey, but try to figure out that system for how that's done. And here's a little something that kind of helps you remember. If it was 8, we know that it becomes ick, because you can remember I ate something icky. Just trying to help you guys find a way with all of this memorization that you're going to have. So that wraps up kind of our complex naming that we're going to have for our ionic compounds. I know it was a little bit longer of a video, but again, this is going to be the key skill from this learning unit, naming compounds. Okay? Last little thing here that we're going to have, little section on naming covalent compounds. When you go on and take organic chemistry, you'll learn a lot more about naming more complex covalent compounds. But right here, we're just going to talk about combining 2 nonmetals, creating what we call binary covalent compounds. So again, how we're going to do this is if we grab two things from the right side of the periodic table, what's going to happen is we're going to have something that's more on the left and something that's more on the right of the periodic table. Okay, so what we're going to do there is we're going to say whoever is more left, we're going to call you the cation and you're going to be written first. We almost treat this like it's an ionic compound. If you're worried about there sort of being a tie that you might have, whoever has a higher period number. So for example, if two things are in the same group, we've got sulfur and we've got oxygen in the same group. Well, what's going to happen is whoever has the higher period number, whoever is lower in the periodic table, that's going to be the one that sort of wins as being the cation. So sulfur would come before oxygen. Again, oxygen with halogen is sort of the exception. Like we saw before, we're going to have Cl come before oxygen. Okay. Once we've kind of figured out who's going to be the cation and who's going to be the anion, whoever is on the left, again, is just named like we'd normally name them. And then the element that's on the right that we're calling more as a nonmetal, we name it like we would an ionic compound. We take the prefix, or we take the root, and then we're going to add the suffix IDE. So we'll practice a lot of problems here, but just think of a simple example here when we have CO2, right? Carbon dioxide. So carbon is named just as we see it on the periodic table. Oxygen becomes oxide, and we use Greek letters to indicate the number of each oxygen that we have. So CO2 is carbon dioxide. CO is carbon monoxide. So those Greek prefixes that we talked about over here, they come into play not only when we talk about these hydrated compounds, but those Greek prefixes are important when we talk about binary covalent compounds. So again, a dicey, long little video here on naming, but naming is a crucial, critical skill. So last little section here on binary covalent compounds, I just wanted to take a minute and go through a couple more examples here. So again, when we're talking about some binary covalent compounds, we can name them sort of systematically. So if we look at the examples that we have here, NH3 would be called nitrogen trihydride, carbon tetrahydride, and then water is actually called dihydrogen monoxide. So we've got sort of a systematic formal name, but a lot of these compounds are going to have common names. So as we kind of encounter these molecules in our course, I'll make sure to let you know the ones that you need to know common names for. Here are three of them: ammonia, methane, and water. I want you to know not only kind of how to name them systematically, but how to name them kind of from the common name sense. All right, so I know an intense skill here, right? How do you practice this, right? So we're going to do this a little bit in class where we'll practice kind of grabbing atoms from the periodic table or grabbing a polyatomic ion, and then just ask yourself the question, if I have these two elements, what am I going to make? Did I grab two nonmetals and I'm going to make a covalent compound? Did I grab two metals, a metal and a nonmetal, and then I'm going to have an ionic compound? And then again, with ionic compounds, it's usually easier to sort of predict the ratio that they'll interact with. Covalent compounds, just like we talked about with carbon dioxide and carbon monoxide, right now we don't know enough to know which one would form. So there's two options and we just need to know how to name them. So trying to find some helpful ways to have you practice, just kind of grab things off the periodic table and practice. Now, unfortunately, there's not an easy way to check your answer, but I encourage you just keep practicing. Find problems, in your online textbook, lots of problems to practice there. If anybody finds a great resource online, please feel free to share it with me so I can share it with the rest of the class as a tool to help you learn how to name compounds.